Guys, welcome to your channel. Today we're gonna learn about the transformers. So transformer is basically a static electrical device that transfers electrical energy from one circuit to another circuit without changing the frequency. And this transfer is done by a term we call mutual induction. Okay, so by the term mutual induction, we can derive the working principle of this thing. So I have a transformer over here. It's an basic diagram, and we'll try to visualize what mutual induction does to a transformer and its operation. Okay, so let's explain the principle of mutual induction. When alternating voltage, say from the primary V1 side, an alternating voltage is sent to the transformer, and what it does is this winding from this winding this alternating voltage travels through, and this magnetizes the transformer core. This is the transformer core, and this alternating voltage magnetizes the transformer core and produces an alternating magnetic flux in the transformer core. This magnetic flux links both the primary side, the primary winding, and the secondary winding via electromagnetic induction, and this electromagnetic induction thing is given by Faraday's law of electromagnetic induction. To state that this changing flux indicates an EMF in the secondary winding. Okay. And if the secondary winding, the secondary winding or says the secondary circuit is closed, or say it's connected to a load, the current which is generated due to the electromagnetic flux flows the power and deliver it to the load thing. Okay, so what is the EMF equation? So the EMF equation is given by E equals 4.44 F N 5 M. So here E is the RMS induced EMF, F is the frequency of course, then N is the number of turns which turns the turns in the winding. Okay, and this phi m is the maximum magnetic flux. Okay. And also there's another thing in the transformer is the voltage ratio. The ratio of voltage between this primary side and the secondary side, and how we write that is given by V1 by V2. Like V1 is, or you can say like voltage primary by voltage is equals number of turns secondary by number of turns primary. Okay, so this is the voltage ratio in a transformer. Now coming into the classification of transformer, and before that uh, the applications where can you find a transformer, like in our daily usable life we have transformers in our mobile mobile phone chargers, power adapters, laptop chargers or adapters, even in the UPS, inverters, a microwave, refrigerators, even in audio devices like DJ and all stuff. Also we can find it in our gully ka naka. You see like power transformer or distribution transformers over there. So it's really common and it has a vast application. Some I have over here, like I have a power transformer. This is how a power transformer looks like. You might have seen in some substation if you really did visit, or these are audio transformers. You can find these things in your phantom power, or if you are really into like music production or basic keyboard recording keyboard from your audio softwares, then you might uh, have a phantom power or a sound card. You can find this type of transformers in the phantom power sound card as well. Then we have this auto transformer. So there is actually a dial in the top, so you can just rotate this dial and get the desired output of voltage. Like the supply is constant but the output is variable based on the input. So this is auto transformer. And also we have this CT, current transformer. What it actually does is in our substation the voltage levels are usually very high, so CTs are used to step down that voltage and measure the current, because even when the voltage changes the current is always same. But for a instrument recording, those high voltages are not ideal to take the readings. And then we have a distribution transformer, on that gali ka naka stuff. It's you can find this transformer usually sitting on H bridge poles. So this type of poles, and there should be a panel. So it's very common for our household or yours, like for each household society. There is usually one or two distribution transformers to maintain the constant voltage. And all your like we are running a lot of inductive stuffs like motors, fans, air conditioners. So when the line goes from this transformer to a household, like there are many household, so there's a voltage drop. To manage this voltage drop, this transformer is used. So this is a distribution transformer. Then we have a furnace transformer. This type of transformers are used in boiler. Okay, then high frequency transformers and isolation transformer. These are a very important tool from the electrical safety point of view. This actually does isolates from like substations, from like higher voltage transmission line, and these are used to like isolate the whole substation from those lines. Like if there is a major fault or some maintenance work is going on, this comes handy. Then we have pulse transformer. You might have seen these things in our old glass tube TVs. So these are pulse transformers. Then we have the rectifier transformer, toroidal transformer, and the resonant transformer. So these are different sizes or shapes of transformer according to the application. Right? So let's dive into the classification of transformer to understand these things better. Generally, transformers are classified based on certain criteria. So, for say like based on voltage. This is a voltage level classification. Here we have two types of transformers. A step-up transformer. So, what's the purpose of a step-up transformer? Is it increases voltages say like this diagram I will try to explain. In the primary side we have 1 2 3 4 5, like 5 number of turns, and over here we have 1 2 3 4 4 number of turns. So ideally this transformer is a step down transformer. If you like reverse this image, or you can, or you consider this side as a primary, so the number of winding it will have is 1 2 3 4, and in the secondary it will have 1 2 3 4 5. So this is how a step transformer looks like in the primary side the number of windings are less, and in the secondary side the number of windings are typically more. So what is affects is it increases the voltage, or you can simply write this as number of turns in the secondary side is greater than number of turns in the primary side. And where it is used in power generation and transmission. This is the application. Then we have, based on the voltage level, we have another type of transformer, step down transformer. and how it would what it does is vice versa of step up transformer. It decreases the voltage. Okay, how? Like of course the number of turns. In this case, in the primary side it will have more number of turns, and in the secondary side it will have less number of turns, like this drawing. Okay, like if we exclude, if we like consider this transformer as it is, then this is an example of step down transformer. So yes, we can say that number of turns in the secondary side is less than number of turns in the primary side. Okay, and where it is used, it is used in distribution and electronic devices like a charger or power adapter. Okay, now coming to the next classification, it's have done classification in the voltage level. Let's do it on the construction level. Okay, so classification based on construction, or you can simply say design. So there are two types of transformer in the construction level. One is core type transformer. Okay, so I have the diagram. The two, I have imported diagram of two. Basically, now we are discussing about type transformers. Okay, so in that code type transformers, the diagram you can see, like there's a core. This thing is core, and the winding. These are the windings. So this is the like for say it's a primary side. This is secondary side, and we have two windings over here. In the winding itself, we have if I zoom it more, this is pixelated, but you can see this yellow part and this orange part. Okay, so this inside yellow part is low voltage connection, and this orange part is basically the high voltage insulation. So insulation is required in the winding itself. What it does is it actually blocks the leakage current in a transformer, as it is an electromagnetic induced device. It's a machine. So in this machine there's a chance of leakage current due to electromagnetic induction. So it's important that the cores are insulated, and even every transformer have a core insulation. Core means the wire, the windings are itself insulated. So basically copper and insulated with some uh, epoxy and stuff. Even some thin films are used to insulate the core. We'll come into the insulation part lately, but this is how actually a core type transformer looks like. Yes, this one is also a design of core type transformer. So just simplify this thing. What are the observations? Windings placed on two limbs of the core. So this is the core, and windings are placed on the two limbs. This you can consider it as a limb. So it's a language to write it. Another thing, the application, the transformers are generally used for high voltage operations. Okay, or you can say operations or applications. It's better to give it applications. Then we have another type of transformer in the classification based on construction itself is shell type transformer. Okay, so let's try to visualize this thing. You can see this has a different design. Like in the core type, there's a laminated core. This core, and this core is also like manufactured from thin blades, and this between these blades there are lamination films. Okay, so this actually, like if you place a solid block of metal, this will have actually more eddy current loss, right? More eddy current loss, and even it will have more core losses. So what we do is, to minimize those losses, we just slice the solid block, and between each slices we place a lamination film to reduce those losses. So this is the laminated core. Of course, this all those pieces are laminated. So even in the shell type transformer, we use a laminated core, and instead of placing the windings on the limb side, we place it in the center limb. So in the core type transformer, we don't have a center limb, the this part, but in the shell type we have three limbs, and we place both the cores in the center limbs. So we can write it like windings are placed on the center limb, and this type of transformers are ideal for better mechanical strength and cooling. So the application of the transformer will be like in those conditions in which we need, like we'll have heavy load on the transformer, and we'll need cooling, more frequent cooling and more efficient cooling. So this are transformers handles like good mechanical strength, as well as we have this air gaps for good cooling. So these are used in electronics, like adapters, chargers, or say voltage SMTs. Even in the SMTs, mm, changeable power supplies, SMPs. Okay, SMPs. The yes, I'm talking about the computer SMPs, the CPU one. Also, SMPs are used in lighting those advertisements and those glowing shop signboards. So this type of transformers are used to for this purpose. Now coming to the classification. Now classification based on number of phases. It's a very common classification. So we know there are two phases. So one is single phase transformers. Unit one uses. So we use it in domestic small power applications. And another one is three phase transformers. And the uses or use it used in by industrial and power system applications. Okay, fine. Then now switching to the another classification. It's classification based on application. Okay, so in this classification, we are actually differentiating types of transformer for its application. Like I have shown over here, there are different type of transformer for different applications, right? Okay, now coming to classification based on application, we have three type of transformers, like a power transformer, distribution transformer, and instrument transformers. Power transformers are generally used in generating stations or like transmission lines, and it operates in full load. Okay, and we have distribution transformers, the one at the gully ganaka, and it supplies power to consumers. What the consumer? We are the consumers, and it does supply powers to us, and it operates at a varying load. Like there are changes in load. Like at the daytime, we basically don't use our lights, and even in the winters, we don't even use fans or air conditioners. So the load changes. So it works on varying load, and then we have instrument transformers, and it is used to measure. Also it is used to protect, like measure what we have two type of transformers: current transformers and potential transformers, CTs and PTs. These are very important instruments. You can find them everywhere, even in the exams, your in your like real life. Someday if you visit a substation or you already visited, so then people always ask about what is CT, what is PT, how these two are different. So it's very important topic to look at, and I will discuss about CT and PT in details in a separate video. So CT basically is a current transformer. It steps down the high voltage to take a current reading of the current in those voltage buses. So this is actually used to measure, and if the current goes higher, there might be some fault, so it's also used as a protection device in substations. And then we have a potential transformer. Potential transformer basically does measures the voltage. So this is the design we have of a potential transformer, and this is how a city look like. Okay. Okay, now we have classification based on winding arrangement, and there are two type of transformer based on this particular classification. The most common one, we have two winding transformer. So all the transformers we have studied above is a two winding transformer. You can see even in the shell type transformer there are two windings. Okay, there are this primary one and secondary one, and in the core type transformer as well, there are two windings. But all these transformer are two winding, the most common type of transformers. Then we have the auto transformer. This is the one we use as a variable voltage source in our laboratories, and this thing looks like this. You might have seen in your physics lab or your power system lab. So this is a auto transformer. This comes in various shapes and size, even from various brand. Those looks a bit different. This is a single phase one, and what's unique about the auto transformer is instead of using two windings, it has one winding. This is the primary side. This is the secondary side. This is the source voltage we are giving the winding, and it works like a tap changing transformer. What is a tap changing transformer? Like you see, there's a long winding, the auto transformer, and it acts as a both primary and secondary. How? Like the voltage side, the side which we are giving, or you say which is connected to the source, uh, acts as a primary side, and the tapping we're taking, like we are rotating the this dial, and we set the voltage over here. We have different voltages like in the dial, right? So these are the voltage. We rotate this thing and change to a particular voltage, and inside what happens is like when you are rotating this thing, this uh, tappings are actually changing. So there are actually many tappings, and you set it to like 100 volts. So this tapping will go over here. Even if you set it, it's like we set it to 50 volts, it will come to here. And then this side is from where we take the connection and connect the load. So this is it, our transformer. Pretty interesting, pretty small, it's cheaper, and the efficiency is higher. Okay, so this is another type of classification which is based on cooling methods, and in this classification we have generally two types of transformer. One is air cooled transformer, other is oil cooled transformer. And in the air cooled transformer, what's actually happening is we have two methods. One is natural air, another is forced air. So taking as example, I am having a rough sketch for say this is a transformer, Here, the surface of the transformer is actually designed like an heat sink, so which ultimately increases the surface area for more cooling. So what it's happening is, in the air cooled transformer, the natural air flows through this heat sink area, through the sink area, and it eventually cools the transformer. So no equipment is required for this type of transformer, and these are efficient and are generally used for less load transformer, so which doesn't have much load, or for those transformer which work for partial loading. Okay, then we have another one is forced air. In this method, what we are doing is we are using some fan stuff. We are using some exhaust fan. For say we plant an exhaust over here which draws air and force it to the transformer, which eventually cools the transformer, right? Then another type is oil cooled transformer. In this type of transformer, we have three methods to cool it. Okay, so the first one is oil natural, air natural. It's an ONAN type. So here, of course, it's an oil cooled transformer, so it will consist of some radiator pipes, some coolant pipes from which oil will flow. There is always, you might have observed, an oil tank over the over the transformer, in which oil is stored, right? So from there you can see, like, if oil is stored over here, and from this tank the oil flows to the oil pipe and cools the transformer. And when the oil becomes warm or hot due to transformer heat, it rises back to the tank. After then, the oil cools in the tank and then again flows through the whole circuit. So this is oil natural, air natural. The air is natural. What air is doing is, air is cooling the oil tank. Then we have oil natural, air forced. In this setup, we have a radiator, and from this radiator, say, like, the radiator forces the air to cool the oil. Then the oil flows naturally to the transformer, around the transformer oil circuit, to cool the transformer. This is what we called an ONAF system. Then the other, we have the oil forced, air forced system. Here we have the same radiator system, but instead of natural flowing air, what we do is we install a pump. Okay, and this pump forces the oil from the oil tank to the transformer oil circuit to cool down the transformer. Then this oil is cycled back to the tank due to the force exerted by the pump, and in the tank the air is forced to cool down the oil. So this is it for this video. I hope you understood the key concept of transformer, the classification of transformer, and if you enjoyed this session, leave a like, and if you have any doubt, the comment section is all yours. You can express your doubts in the comment section. I'm always here to help, and if you want this note will be available in the drive link. You can also join my Discord for all this content, electrical contents. Also, if you are new here, do subscribe